Hello and good morning. Welcome to what will hopefully change to be a fun day. Right now, it's not because we are in a lot of pain, to be frank. I woke up super early and I was like, yesterday we talked about we had this performance issue where if our app runs long enough, we start to see what we assume to be some leaking, but data builds up, garbage collection sucks, and that's no good. So unless we fix it, the device will have a meltdown or the app will crash. Yeah, no good. I was like, that needs a lot of thinking. I'll start early, and I got a hour of good thinking in, and then I looked at our priorities from yesterday, which is the top three is fix the leaking or performance issue. We wanted to detect when a call is running, and then handle mic output change. And then there's a fourth thing in here I think we haven't really talked about yet. But if we think about the idea that we were working on a couple of weeks back, or last week actually, where we were just passively recording the microphone on a call to analyze it later. One issue we were talking about back then was assuming you're on a call with just one other individual and it's a 30-minute call, statistics will say you're likely to speak 15 minutes out of that 30 minutes, but right now we're recording everything, taking up twice as much disk space as needed because half of it is just silent time where you're recording, but not really recording anything but silence because we're only recording one side of the conversation for privacy reasons. So back then, we were talking about muting or stopping recording, ideally, when not speaking. We didn't solve that problem, but we had it on the back burner of things that we needed to do. And then this morning, as I was thinking about the leak, I was like, this is likely in code that's not ours. And this is already so complicated, I barely have any idea what's going on. So chances of us fixing it at a root cause easily is pretty darn slim. But we could probably work around it by solving the old issue, hopefully, where if we stop capturing when the user stops speaking and just pause, stop, flush the arrays and everything, and reload when the user starts speaking again, we can keep the leak to a close to zero. And if garbage collection works, we're no longer host. Not exactly a root cause fix, but it would definitely work. So that was my thinking this morning. And we're now half knees deep into a rabbit hole of how do we detect when a user stops speaking? One would hope that there's a simple flag on a media recorder saying silence detected. At last, we're not that lucky. Computer does not handle this for us. APIs does not handle it either. So I was looking around to see if anyone had fixed this, and I found someone that's doing something that looks like they're detecting silence, and their code looks close to our audio visualizer component from the code that we stole on Monday or borrowed nicely. Hooray for open source. Um, so it should be fairly transferable, and that's basically where we're starting today. So fix leaking. Let's just draw on the screen here so we can see what we're up to. So this here, like we definitely want to fix Check performance on low-end devices, but that's for later. We'll do like this. Can we, one, stop recording and processing when the user stops speaking? Two, when it happens, flush everything except model. Because the model is like, that's like 300 megs of AI model that we have to load. We don't want to do that all the time, but we can definitely flush everything else. Probably stop the stream. Maybe stop the stream. No, we can't stop the stream. We still need that. But we know for a fact that the stream is not leaking because it's the same approach that we take on recording in our old proof of concept around post-processing audio. So stream is good. Model is not. Or rather, we assume leak to be around array and model output. If we pause output, flush, are we then good? If yes, we're in luck. That's what we're hoping for. If we're not in luck, we'll be that much wiser, but we then have to still, like, we have to keep looking. But that's okay. We don't know what we don't know, so we have to try. That's basically where we're at. Um, so let's see if we can build something that will just detect whether we stop speaking. And if we do, we'll make the screen green. How about that? We'll see. All right. So, in looking around, I found someone who made something called Park. Not even sure what OpenTalk is, but shout out to them. Completely open standard-based tools for modern communication, yet delightful user experience. Mm, can we see it? Simple WebRTC. Nice. WebRTC, if you don't know, is used in like if you're doing calls platform, chances are you're doing WebRTC. It's like the way to do it. Slack did it. That was like powered Slack calls, I assume. Basically, any calls thing out there is based on WebRTC. I have some friends who are working on Pop. Isn't that called Pop? Uh, Pop.com? Is that a thing? Yes. This. Have some friends who's working on this. Screen sharing, a bunch of like ex Slack folks. I don't even want to know how much they paid for the domain, but definitely using WebRTC as well. 90% sure, not 100%. But shout out to Pop. Shout out to the ex Slack folks. They are brilliant. Yeah. So here, what they do in this code that we were inspired by is, let's see if we can read through this. They have the audio context, which is null here, but they take the stream, which is just a good like media recorder stream output. From this, we can create an audio context. An audio context is just a library. I read this morning. I did not know that, so I don't want to sound smart here. But if I understand it correctly, it's a library that can build a context upon the stream, which you can use to then like do visualization and other cool things. The audio visualizer that we have already uses this. Um, Again, we borrowed this, so I have no idea how it really works, except to do cool things and visualize how a call looks or how our microphone, the squiggly line when you speak. Um, Here, there's a bunch of things around event emission that we don't really care about, but the cool bit is the build up a speaking history, and the history is, let's see, history. It's just the current volume, I think. Yeah, we push the current volume. Um, Hold on. What would does this? We need to debug this to see how it actually works. But we're keeping track of the current volume of the speaker, I think, and whether it's above or beyond a threshold. And if this loops and checks every 50 milliseconds, so, and our threshold here, like if history is larger than 2, that means we have more than 2 occurrences. So for more than 150 milliseconds, we have detected a output that's higher than threshold. Then we can with confidence say speaking. And if that's not the case, the history will return to 0 and we start over and speaking will be false. So we need to build a copy of this that does not use all their libraries, but still does basically the same thing. That's what we're up to. Fun. So we'll park this on the side, have it for inspiration, and we'll get to work. Mm, This is the audio visualizer, and what it does, I think, have it. Oops. We have it somewhere. Maybe I removed it. What it does is basically just oscillating when we're speaking. But if we're not speaking or we're speaking super low, we'll be below the threshold, and that's fine. So if you're a silent talker, the tool probably won't work. Or you can we can make the threshold adjustable, I suppose. But let's see if we can get this working. Maybe we could actually just bake it into the audio visualizer component. That would work too. Hmm. I'm looking at the streaming software, and there's a probability that there is a delay between what I'm saying and what you're seeing. And I'm curious if the desktop capture, so what I have on my screen and the audio, whether that's out of sync. If it is, please let me know in the chat. or if it makes sense, I would appreciate it too if you could let me know, because I really don't have any idea. Otherwise, I'll have to circle back later today and just check. All right. Hmm. So here, I think this stream and visualize. So this, like every time the stream changes, which is, let's assume a lot, this will like be the call. Um, let's just check. I assume this is like called all the time. So we can just use that for now. And I'll bring this one over here. Yeah, you see, draw visual is like firing away. Every single, like, the stream is changing all the time, so this makes sense. Okay, we'll stop. So maybe we can just, this might be poor practice, but we'll do it anyway, and then we'll fix it. But here we'll say, um, check audio output. Mm, What does the FTT size mean? Representing the window size of the FTT fast Fourier transform. What is a fast Fourier transform? An algorithm that computes discrete Fourier transform sequences. Okay. What is the difference between having a large window and a small window then? Oh, here. A higher number will result in more details in the frequency domain, but fewer details in amplitude. Okay. So if we say this is a test, this is a test, and we stop and go back and say, hey, 512, do we then see just thinner graph? Is that it? Oh, less, yes. Okay. Hmm. Hello, 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 hello. Interesting. We'll just, for our own sake, was 228, 248. Okay. And the reason we go with 520 is that's what they do over here, for better or for worse. I wonder what this does. This is a test. This is a test. Test, 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 test. So smoothing, not so jagged. Not sure if it really makes a difference, but hmm, probably need this. And we will, what is bin count? Sometimes I wish I was great at math. So, okay. The buffer length is the same as frequency bin count. Let's hope we don't have to think too much about this. Mm, we have our source node here, which is the same as our source. So we can, okay, so we can just do this and live happily ever after. So our source, create media source from stream. This is this one. And whoops, threshold is -50. Good. The analyzer, audio context. Do we have that? We have an analyzer. Hooray. So this is the looper function. This is where the magic happens, and we'll try and implement that. And my thinking is, since this is called, like the draw visual is called all the time, we're just going to create a function here, and we'll see if, screw it. We'll see if 50 milliseconds have passed since the last time we made a timestamp somewhere. And if not, we will wait. And if 50 milliseconds have passed, we'll reset the timestamp, run this logic, and yeah, we'll go from there. So check if 50 ms has passed since since this function was called last time. Hold on, something happened. How does use ref work? Because like this is inside a function, so I would assume this would have to be declared somewhere outside the function for this to really work. But I also see it used down here. Note that useRef is useful for more than the ref attribute. It's handy for keeping any mutable value around, similar how to use an instant field. So it's like an instant field. It's like something you would just declare. Okay, good. We can work with that. Mm, This is our magic logic. Magic ends. Now, I want to access things that we have down here, but I assume we cannot do that. Is I guess the scope ends with a function, right? All right, we'll just do something else. We'll make our life simpler and just take this. Then we'll figure out how to make it pretty later. Uh, Spaghetti code for the win. Here. Okay. So we can check. Have our analyzer, have our bin. And hacker hardware emit we'll just replace with console log for now. History 0, threshold. Um, do we have speaking somewhere declared? Speaking history. Okay, we'll start. Let's just try and do like this and say con speaking use ref false. We have our speaking history, so we can just remove these. Good. Mm, get rid of these. Mm. So depending on whether we're speaking, this should be green or red. Like this is, we have no idea whether this works. Clearly it doesn't. The question is why. Mm. DevTools, Infinity 50. Assigned to constant variable. Yo, but who? Line 29 or 35? Hmm. So something is complaining. Who and what? No idea. Oh, Matus, thank you for tuning in and thank you, man. Um, we'll see if we can get this to work. So the question is, what stopped working? Well, what made it stop working? Is it this thing here? We can just, is that it? Oh, here. It's a constant. So if we change this to a LED, actually we get the complaint right here. So if we change this to something that can change, like, should we use state for this? Is that what? Is that it? Uh, run it. So we're no longer fucked because, ta-da, we're good again. The question is, was it this or the other thing? So we're red. We are red all the time. Let's load the model just to see if this actually changes anything. It does not. All right, but the good thing is it's red, so now we can stop or we can start debugging. Okay, something is definitely breaking. Let's pause. Set, not set, not a function. We get a lot of output. Oh, I see. It's because of this. Fine. Um, Not what we're looking for though. Cool. Let's fix it. So here. Mm, what did it say? Did it say not set? Said not? Doesn't matter. We don't need it right now. Mm, we'll stop this. At least one of them. Let's go back into Audio Visualizer to figure out what's happening. I think first thing we need to figure out is, do we even get in here? Console, debug, do we see this? Because we definitely see this. That's filter, current level. Mm, volume change. There's definitely volume change. If I'm not speaking, it's pretty stable, and if I start speaking, so what volume change works? That's good. Volume, 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 volume. If I speak softly, then what happens? Cool. I mean, that's basically all we want is this, right? Because we can just say, is this above or below? Volume change, who, this? I suppose that's exactly what this is doing. So it's working. And this is running. Wonderful. So it's our history that's not working. Hold on, we'll do something else. Um, so we're locking our current volume and our threshold. Our threshold is -50. It's actually pretty good. So I think our threshold might want to have that as like 70 or something. Maybe 70? 70 seems good. 70. Let's just try and say is speaking. I'm going to say current volume is current volume smaller than threshold. That should do the trick, right? Let's see. So we're speaking. Oh, okay, okay. Hold on. All the way around. Are we speaking? Yes. Okay, if we keep speaking, how long time will it be true? Actually, it's pretty good. So we don't want it to stop too prematurely. So that's why we have the. So this is like for a single frame, as long as it stops or I keep speaking. And we can just set thresholds around this. So if it's like, if I stop speaking for more than 2 seconds, we stop. This is brilliant. Hmm, I like this. I'm tapping my desk right now and it will not detect that. What if I'm clicking? I'll try to click profusely. I have to bang the mouse basically for it to start detecting. Okay, I like this. We're in business. Paincave now became. Oh, this is green. Hello? Did, something is working. Maybe it's not what we expected it to be, but something did happen. Hmm. Okay, so it's our logic that's wrong. Now I'm curious, what happens if we go back and change back the values that we like added, or so like the FTT size and the smoothing constant? Will that change anything? This does not seem to like take a hit on performance. Hmm. Let's make this a bit clearer. So we will stop this thing here for a second. Let's not do that. And let's just say, and if if we're speaking and current volume, current speaking state. Okay. So if our current speaking state is the fact we are in fact speaking, you want to see if our current volume is smaller than our threshold, then speaking is false. Else if we're not speaking, then speaking will be true. And we'll just say if current speaking, if that's the case, we want to lock current speaking state, speaking. So now we should only see a log output whenever our state changes. So if I keep talking, nothing should happen. Unless I stop talking, we should see it go back. Okay, so if I hold on. I slipped up somewhere. Hmm. Hmm. So we'll see if we can get chat or Copilot to fix this. Console lock the value of speaking if it changed since last time. Okay, much better. So this clearly works. Like if I keep speaking, I should just say it's true until I stop speaking. That's good. And then down here, they had this like history threshold, so we stop seeing all the back and forth all the time, and we can make it a bit more smooth, and we can start experimenting with that. So, oh, this works. Hold on, you can't see this. I can. This is pretty cool. Ta-da! Holy shit, this is awesome. And then now it's just about finding a way to make this smooth enough. So all these like we don't see the flashing. Ideally, it should just like stop speaking if I like, or should like only switch if it's been like I don't know a second. But we can track this and we can monitor it and we can like find the sweet spot over time, make it better and better. But in terms of functionality, this actually works. I like where the Paincave is taking us. So if we set up some boundaries around this, we can wire the model into this and just like load the model and turn it on and off and see like it should work, right? Like for all I care, the threshold could be the same as our window size for transcription, which is like I think 15 or 30 seconds. So if I stop speaking for like 15 seconds, it'll change, or 5 seconds. Hmm, not too shabby. So right now this logic sits in the draw visual. The question is, do we want to move it outside? Oh, let's just change this back to 48, remove this, just to see what happens. So does this actually make any difference? It becomes more sensitive, I think. It's definitely more sensitive. The question is that the smoothing or the window size or the FTT size? Let's try turning on the smoothing. Yeah, Matush, we're making way, man. I like it. So turning on smoothing definitely helps. Like it now picks up if I tap my desk. At least if I tap it hard. Let's try and reduce the window size again. Like this is Non-scientific testing, ladies and gentlemen. But it's the same. I don't think it makes a meaningful difference here. But that's okay. Mm, we don't have any control over the draw visual, but that shouldn't matter since we have the elapsed time, right? So this is basically the same as they're doing over here, where they just have a 50 millisecond loop because we have the elapsed time. Let's just see. Skip this because we now know this isn't working. We'll skip this and say else and just console log. Let's pass hard on the hard work. Okay, we just want to see that every once in a while we'll see this. Happens a lot. That's fine. Good. That means we're not doing it all the time. We're just doing it enough. And we can control how often do we want to do this. I like it. We'll skip on this. And so let's just explain this for our dummy brain here. Our speaking volume is lower than our threshold. We're not speaking. We need something first. We were speaking, but we were not speaking, but our speaking volume is higher than our threshold. We are now speaking. Great. And I think we saw the most back and forth here when going to true. So here, what they're doing here is saying, okay, we have speaking history. um, if so, we're not speaking, but we are speaking. And if that's the case, we wanna we wanna wait. In this case, we'll wait 500 milliseconds. We change to speaking. Wait, 10x 50 ms cycles. That's not exactly what we're looking for, but that's what's gonna happen. Um, at some point, we would need to reset. Let's see what they do. Push 0. Let's just try and see what happens here. So it should wait 500 milliseconds. It does not care. Hmm. So it still changes super fast. It feels like it's too fast. Hmm. So what happens? Nothing. Why is that? Does this make a difference? Maybe. Maybe not. I don't think so. All right, let's add some debugging stuff here. So log speaking history, length, please. New, this. Okay, so, mm, what? Um, wait, why do we have this thing down here? So if current speaking state is different than our current state, we'll set the current speaking state to. But we're already doing that up here, right? Hold on, go away. Hmm. Wait. Oh, can we do this? Is that a thing? So does this? This definitely does not work. So it's red all the time. So we definitely needed that. It was here for a reason. But I do not understand what's even happening. Cheers, Matus. Thanks for stopping by. And now shit's broken all the time. What's happening here? Let's go back in time. Rewind. There we go. Reset. We need to make this smarter so we can actually understand what's going on. We need to make ourselves smarter. Hmm. Does this even matter? So I think it doesn't, right? It's just it's just those two lines. Hmm. So what it's really saying here is just what does the current like the current? Is there a definition of this? Mutable ref object. So that's our reference, and the other thing is just the container. Okay. That's our assumption now. Hmm. Can we get rid of this? Get back into this and say current? Then what? Let's see. Does this work? No. Why not? Okay, so let's debug this. Hmm. Was not speaking, but changing that. No longer speaking. Okay. Rerun. So these will never get called for whatever reason, so we need to debug that. Console block current speaking state. Mm, Threshold. Let's just do one more. And speaking.current. Oh, should this be speaking.current? I think so. Yes. So we were always making a false statement if we were using speaking.current. That should do the trick. So if we do this, restart, this is better, right? Yes, certainly. So we're making way, ladies and gentlemen. We found our buck. Now, let's see what they do here, because that's basically what we want to do. Grab this. That's why I moved these two around, or swap the orders, just so they match whatever they have down there. Because our assumption is we want something like that. So we have our speaking history. And here, we'll need to say current. Okay. We're gonna steal this and see what happens. Current. Okay, let's see if we can make sense of this afterwards. Let's just run it. So it's red, and it definitely stopped working. No, we are killing a rep somewhere. Okay, we'll reverse and we'll do this ourselves. Okay. Mm, let's just try and push to it and see, like, can we actually work with it? We can. That's good. What's the length? So, seems all right. If we keep speaking, or like keep just okay, so it only adds every time it changes. Could that kind of make sense? Hmm. Every time it's basically just a count for every time it's green. Hello? So every time it changes to the screen, it will do a one. Add one more. That makes sense. That's what we expect. So what we're looking for right now is we don't want to change to like to stop recording as fast. But the current speaking state does not really matter. So it only changes if it's current. So instead of this, we need to see, let's think. Right now it just changes when the volume is lower than the threshold and say, hey, we'll change to red, you're no longer speaking. Great. We want to keep recording somewhat past I stop speaking to make sure it doesn't go back and forth all the time. So we still want to, like, we don't want the value to change if it's already changed. So we still need to do the speaking has to be true, but our condition instead should be has enough time passed of me not speaking. So we'll say our current volume is lower than our threshold. Start adding to our history when history is large enough, change state and stop adding to history. So if we're still considered speaking and our history length is smaller than 10, we want to push one. Else, if we're still speaking and our history is larger or equal to 10, we can do this. We'll say, and speaking history. Is there clear? What does shift do? Why do you suggest shift? Removes the first element. Is there a remove all? Can we just say empty? Right now, this should be length of 10 equals 50 times 10. Okay, let's run this. Did we break it? Huh, it still changes rather fast. Uh-oh. Was it this one? So I suppose it's still working now. Okay. Hmm, history. Hmm. So this should work. It definitely does not. Hmm. Oh yeah, we pushed into history. So now it changes less regularly. Okay. Is it because we're never setting this again? No, we are. Now things are moving so slow. This only runs every like every 2 seconds. And change to red, and then after 20 seconds. Mm, um, Constraints. Turn mic delay before stop speaking equals let's just say we want to wait 4 seconds. Length delay count equals mic delay before stop speaking. Divided by 50. So this should do the trick. So I can start speaking and immediately change to green, and it should wait 4 seconds until it stops. One. Seems right. I think it works. Then you can argue, is 4 seconds too long or too short? Doesn't really matter. The fact is we can adjust this, which is super cool. I like this. The thing is, we can probably do the other thing for turning it on as well. So if it's just a quick tap or something, you don't want to turn it on for sounds that's like crazy. Like if I tap something that's like blip, you don't want to turn it on. But if I start speaking, it'll be like a continuous stream of. But the delay should probably be significantly less, like I don't know, 200 milliseconds or something. That should be able to like avoid the most clicks and the most weird odd sounds, ambient sounds. Okay, so we'll try and do one more. Delay before start speaking equals 150. That's 0.15 sec. Hmm. Stop speaking delay. We'll say const start speaking delay, and that's 3 cycles. Cool. We'll move these. Excuse me. So here, if, hold on, if we're not speaking, else, if we're not speaking and we are within the good, we're going to do the same as down here, but I'll say this instead of this. And enough time has passed. And enough time has passed. Let's try. So if I start speaking, I'll wait 4 seconds, but it will only wait 150 milliseconds before turning on, which is great. That should, maybe we need it to be a bit more. Maybe a quarter of a second is too much, but I want to like avoid picking up as many clicks and weird ambient sounds as possible. So I'm gonna bang my mouse and my keyboard for a bit. A table. Mm. Okay. I wonder like how this influences the output, but we can like figure that out. But I think we actually have a working prototype. I think this is good enough for now, which is fucking amazing. I did not expect us to like even solve this today. So let's see, how long time have we been here? Um, do we have? I think I have a timer somewhere. Where is OBS? An hour and a half. An hour and 40 minutes. Amazing. Really solid. Um, right now it's in our drawing component or visualizing component, which is fine, so we can see it work. We probably want it to be outside so we can now start testing performance. I'll just draw a line in the sand and say, hey, screw our speech detector component. And now we will just save this and say prototype working. Save game complete. Now, what do we do next? Do we split this out into a separate component? Like the thing is, like we can run this application for as long as we want, so it's clearly not the stream and it's not the chart and it's not anything else that's like making our performance go south. It's the moment I hit load module, something happens. And our thesis this morning and yesterday, or actually just our thesis I came up with this morning before starting our stream is we load our model and we start transcribing. That builds up something, a cache or a leak somewhere that we don't like, and it ends up just blowing up and ballooning. Eventually, our app dies because garbage collection cannot figure it out. If we can detect when I stop speaking and just pause and flush, we hope we'll never run into this issue. That's the thinking. So I think the next thing we have to do is to split this out into a separate component that we can listen to. Not even sure what the right approach is to do this. Like, keep in mind, I don't do React, I don't do web code whatsoever. Yet we are doing this or trying to. So we need to figure out how can we make this not suck in terms of performance, be built somewhat right for it to work, and we can listen to the state change and act accordingly. So I suppose that's what we're going to figure out. Mm. Yeah, you can see our app running is down here. We have many things that like taking up far more resources. Chrome. OBS, which we use for streaming. There's a lot of things. So this is not a concern. I never really became good friends with the activity monitor on Mac. I can't really figure out what this means. Like, we are quite idle, but yet we are at a high utilization here. Something doesn't add up, but that's okay. We don't mind as long as my machine works and you can see what I'm doing. So split this out into a different component and wire it up to our transcription and hope performance is better. That the game plan? Let's go back to Excalibur. We have that somewhere. Just update our chart. Excalibur. Switch to tab. Where are you? Here we go. So right now, gonna need a big here. We have this, and it's really good. We're just gonna maybe this is too much, but we're really, really happy we were able to solve this. Super cool. And then we need to figure out how we flush everything and hope our performance improves. That should fix our priority zero, which is fix the leaking or the performance issues. Hold on. You can't see what I'm doing, can you? Hmm. I'm looking at Restream, which I use for streaming at my other monitor, and you're way behind. And I'm not sure if that's Restream. I'm gonna reload and see what happens. Or if it's okay. That was better. It's actually just Restream itself was slow. So you can now see what I'm seeing on my screen as well, which is great. We don't have a streaming issue. Um, I'm gonna go on a quick break for like 4 minutes, and we're gonna separate this out into a component, and then we'll wire up to our logic and see what happens to perf. So be right back, bio break, and then we'll continue. So we are back at it. I was thinking, rather than just having a pretty be right back screen, there should be something happening. Maybe I'll ask AI to create like 10 bogus ads for what we're actually building. That would be a interesting thing. Or we could make it more interactive, maybe. Like there's a bunch of things I would wish I kind of want to get feedback on. And maybe we could make I need to check out what is this like capabilities of streaming platforms actually. Might be that I just have to show a QR code and like, hey, answer these questions or this questionnaire in a type form or something. But it would be interesting to sort of make it more interactive and fun. Even just have a timer of like be right back in 4 minutes and have it count down something. Then it just like sitting there being boring. But bogus ads for what we're building would actually be fun. So like good old like Flow TV kind of ads, and we can run it and see what the world thinks. Hmm, that's stuff for another day, but we might have to do that. So let's try and let's try and do this. Separate this out and incorporate it because we actually don't need the visualizer itself. So maybe we can just butcher this. And so what do we want this to be? We basically just want this to emit events or emit something that we can listen to in our logic. So, um, how does event emitters work? Sure. So if we just um alternative to event. True, this is close to like RX, actually, now that we think about it. Hmm. Also seems like a lot to import RX just to do this. But I really like RX. It's a lot of fun. And wicked to wrap your head around at first. Okay, so we'll do this in tiny, tiny increments, I suppose. Bring this over here and silence detector. Do this. Stop running for now. Mm. Do we do we have to worry about React for now? I'm not sure. Um, so in our app, do visualizer here. Just set the stream. We can do whatever. Um, so Usets is recording. This one does. Record a ref. Yep. We don't know if it's recording yet. Is it recording? We do not know. Okay. We have so much stuff. Okay, we need to. I think we need to clean up. It's hard to fix anything in a house that's messy. So let's. Hmm, export function. Oh, this is so entangled. All right, we don't untangle this yet. Hmm. So we're still good. Stream is set. Do we? We definitely see this. Mhm. So this never happens? Is that it? Hmm. Recording stopped. We're just gonna add a bunch of console log and see what happens. Have data available. Um, yes. Set stream is working because this is the only place we do it, right? And no, yes. And now visualizer works. So stream is set and something is happening. We can start to load the model and record. Oh, recording started. Yay. stop. So the thing is, as we keep speaking, historically what we've seen is the data available keeps going up and up and up and never really drops unless it stops speaking for a long, long while. So things will get kind of messy, and we need to figure out how to deal with that. Right now we can see our words per minute, etc., keeps counting. It's working as well as we would like, I think, but we just need to figure out how to stop the performance from going haywire, because right now we're sitting at data around 26,000. And let's just continue talking for a while and we'll see what happens, because there's a bunch of things that we, with this, actually want to build and want to enable. One thing is, when you speak, we want to be able to show the user words per minute. And words per minute is a proxy for, is your like your audience that you're speaking to, are they able to understand what you're saying? Do you speak slow enough for them to be able to grasp it? The sweet spot is somewhere between 120 and 160 or 150, I think. I can see I'm speeding all the time, so I need to teach myself how to slow down a bit. Um, the good news right now is our data available seems to sit around 25,000. Maybe that's okay. I'll stop speaking in a second and we'll see if it goes down. And that should, like, that's what we want. We want it to go back down to zero when we stop. So I'm going to shut up for a bit and wait 30 seconds, because that's our window for Whisper to process. So after 30 seconds, it should drop off a cliff real fast. So do we have is there a clock app? Clock? And we will just say reset the timer and we say start. So right now we're actually seeing my concern, because it still hovers around like 15,000, and it goes up to 25 when we keep speaking. We could see in the output over here that it's looping in itself, trying to decipher what that like 15, 16,000 is. My hope is we can just say, hey, you're no longer speaking. We know that because we just built the logic. So when the window has passed, we'll turn everything off and like force data to go down to zero, and we'll live happily ever after. I'm gonna like pause again and just like wait for like 45 seconds, and we'll see what data sits around this time. So now our stale data window is like 19,000. We'll try one more time and we'll see what happens. But this is like that the concern of mine is this happens. Like things grow and grow and grow, and eventually things will just collapse. So we can see historically when we speak for like a minute or two, or like for like just a minute, the data went up to like 25,000, maybe 24. Now we're sitting at 32, and it'll keep growing. So we just have this like slice that gets bigger and bigger and bigger, and the window that we're working with, or that's meaningful, is way smaller. What I assume happens then is also our model has to like process all this garbage data to get to the point so our accuracy goes down and the processing cost goes up. And all in all, we are facing a bunch of terribleness. So right now, the data window is actually bigger than the window full of speech that we processed up front. So this is the core issue. And we can see here that our electron helper is starting to like really pick up in terms of like processing. And still not as much as we need for like streaming, but it's wild that our tiny helper tool here need this much CPU, and it'll only go up and up and up, and eventually garbage collection will come around and say, "Hey, I have no idea what you're doing. We're gonna shut you down." So that's what we were up to, fixing this, and I'll try and hit reset, and we'll see what happens to our data window after another 45 seconds of silence. So reset actually does something. We can also see the CPU dropping to half almost, like in the high 70s before, at least in the 70s. So that dropped. So room for optimization here. So let's see. Let's go read some React documentation, because is React just for UI, or can you just build a basically like a state machine in React or something? Um, I'm not sure what the right approach is. That's my issue. I think like there is ways to do this, and we can just hack it, but I kind of want it to be in the ballpark of something reasonable. Mm, none of this requires any UI. What happens if we click reset? Where's the reset button? Reset button. On click. Aha. So it just stops the recorder and starts it again. That's actually what we want to do manually, I suppose. Hold on. Recorder ref. Oh, 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 oh. Mm, I need to figure out what this means for our worker as well. But basically, what we want for now is just to mimic what we do with reset, I suppose. One thing I am concerned about is what does this mean for, yeah, that's what I thought, because we need the stream. So the moment we kill the recorder, we kill our own ability to listen. The question is, what is the cost? We know for a fact the cost of running a stream is not high, not really high. So do we want to have two streams, one for listening and one for, or do we want to see if there's another way? Because it's this stream that we are relying on. So we are relying on the media recorder stream. We're telling the media recorder when this happens, we're saying, media recorder, please stop. And then start. Maybe it's enough to tell our model. On data available. That chunk. How big is this? Hmm. On data available. Looking at this one over here. We'll get an event and eat up data. So the issue is we're always getting data, I suppose. That was what we were running into before. Like this never goes down, that's right. Or isn't that right? Hold on, let's run it. I just want to be sure. Because what do we use chunks for? My assumption here is chunks will just get bigger and bigger and bigger and bigger until because it's on start. So the only thing that will like reset our chunks down to 0 is a reset. Let's just validate that. Console log chunks length. Let's take a look and I'm gonna load our model and we'll be good to go. Chunks length. No. Why are you not? So we're hitting data available and size is larger than 0. Set chunks previous. I'm not sure I get that. Can we add logic here and just say when this happens, we want to do stuff and then return. I'm gonna move this one in here as well. So chunk length keeps growing and growing and growing. And we insert the data. And chunks is what we want if we need to like reset. If we want to store it all in a file, I suppose. We'll say chunks, parse this into a file because this is where all the data goes. I'm curious whether we actually need it though. Like, we need to check whether we need to check whether we use chunks for something elsewhere. I don't think so. Like, I could see a scenario where it makes sense to save it. We did that in our old application. That was really helpful if we want to do some post analysis. But if we're not doing post analysis, we don't really need it because the model just takes the stream, as far as I know. So the only time it hits resetting is if we're actually hitting reset. Hmm. Okay, we know what we want. Let's see. Oops. The chunks. Hmm. And this uses chunks. So like, if I understand how use effect works, every time one of these dependencies change, this will run, right? So whenever chunks change, this will run. We can probably just test that. Console log. We're gonna start. Then we should see. Yep. So we update chunks, then this happens. We update chunks, then this happens. And this keeps getting bigger. So every time we have to make a new blob, that gets bigger. On load end, what do we use the blob for? Okay, so what happens is we take all our chunks that we saved, which gets bigger and bigger and bigger, make a file reader, and we tell the file reader, hey, read this massive chunk of data. And when the loading ends, We do a bunch of things. We turn this into an array buffer. This gets into decoded context. Not sure what get channel data means. Oh, interesting. Wonder if this just gets longer and longer and longer. Like our max samples. What is that? Where do max samples is whisper sample? Mmm. So it'll take and I'll slice it and remove everything. Forget the audio. We remove everything but the last. This is our bit rate and this is our length. So we say bit rate, which is bits per second, and our length, or sample length. The bits per second times length means we are looking at 160,000 bits. That's our slice. And it might be we have a gazillion, but we have to like load that gazillion just to remove it. That must be terrible for performance. Or at least we're loading a lot of data that we don't need to load. We know that much. Now, where did our loading stuff go? And this happens on air, like on every chunk. Fuck. Here. The question is, what strategies do we have? Like here we pass the mime type to make it a blob. So we can't just take chunk length because we can assume our audio length, which is the decoded audio, and our blob length or our chunk sample size, data size is different. So we can't just say only select that many. What do we do? Like right now we just like load everything to slice out and get the last necessary, like get there, only get the data that we need to actually process. Mm, we'll just write that down. So Only keep the worth of audio. I'm kind of inclined to say no, we don't want to do this here. That might blow up though, so we don't want to do that just yet. Hmm. So state, does state bubble up or only down? So you can pass parent state down, but not up, right? Is that how React works? Can React bubble up state? Hmm. Wait, what? So we have our function, which is app. That ends here. This ends here. This ends here. This ends here. I'm not sure I follow this. Either way. Hmm. Nice. So, okay. Does this mean we'll need this on the side? Like this. Now that we know what's blowing up our data, we'll add more state to this wicked machine here and say listening, sorry, speaking, set is speaking, set speaking. Okay. And okay. We won't break this. Instead, take our silence detector here and set speaking, green, turn, here we'll just do this, this. Okay, maybe there's a better way. I don't know about it yet, but here, we'll move this bit in here. Silence the detector. Mm. Mm-hmm, mm-hmm, mm-hmm. So we could just do the same for now. Do we still have this in here? Here. Um, Evaluate speaking. And we just do the same here and say use effect. So every time stream changes, we shall call okay. Here we'll do the same for good measure. What's the fuss? Hmm, hold on. Okay. So here, export our silence detector. We're gonna add that in here. Remove this. Let's say silence detector. Get a stream. You get speaking. Set speaking. Okay. Whether this works, who knows? We don't have the visualizer in there. We now have this. I assume this will blow up. Do we have any console log statements? No, we don't. So we'll just like do this. Running. And wish us luck. No. Okay, that helped. We changed this to a JSX, so we might be able to get away with what we did before and not render anything. Let's try that one more time. Yep. Speaking false. So now something is happening. Our speaking thing does not seem to work. Um, Something is not right. That's okay. Actually, we should be able to, like, this should work without even without starting the model. running is speaking false. Like we're seeing this. And that's a good thing. Mm, but what are we missing? We're missing something because it seems like it's only running once. Okay. Connect and say draw visual. This is in the stream, and this is valued stream. This seems self-contained over here, so there's nothing outside doing things. I think. No, there's not. Right? Here, 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 here. Oh, that's just it. Okay. So, if that's the case, hmm, but why is our stream not changing? That is some weird stuff. If we do this and this, and say this, we'll just try one more time. We can see this clearly works. The other one doesn't. Hmm. So what's the difference? Canvas props. Mm, can't be right. Canvas rough. No, maybe this one. I wouldn't know it until we try it. Let me go up here and say Something, something. No, doesn't make a difference. Mm, just test this for good measure. Runs a lot of times. Cool. All right, I'll go on a big or short break, and I need to get something to eat. So I'll be back in like 5 minutes, 7 minutes maybe, while I get some food and think about this. So be right back. Stay tuned. We'll figure out what's going on. So we're back at it. We need to figure out why one is working and the other one is not. Hmm. And your guess is as good as mine. Hmm. I'm gonna just try and do whatever it is that we're doing over here, do it on the other side, and my assumption is eventually things will start working because right now it doesn't, and we don't know why. Hmm. So this is largely the same. Less things that we do, but otherwise, use callback, stream. This happens once, at least. Is Are we just doing it wrong and passing an empty stream? Is that it? Media stream. Okay, that's not it. Is it because our stream doesn't change? But it should, right? Or stream is a stream. And here we depend on stream changing and visualize as dependencies. We could just see, is it stream or is it visualize that actually makes it change? Hold on. Or both. Might be just both. It is both. Mm, Now we're not loading for whatever reason. No good. Hmm. Mm-hmm. Nothing here really changed. Yeah, we removed some locks, but that should not break things. Mm, Shouldn't break things either. No. We save and hide this. And no dice. What the fuck? Excuse my language. Uh, stash. Save this for a sec. Hmm. Okay. That works. Hmm. And over here we have screw it. Okay. We'll keep our local reference of speaking here as well. Let's say, where did it go? Mm, 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 mm. Mm. We'll just copy this and fix it up after. Like this. And say we have our local thing. And here we'll just call set speaking true. Set speaking false. For sure, not good practice, but YOLO. Let's run this one more time, see what happens. We're still good. Green. Yes, definitely works. Now we go into app. Here app. And go to the end. One more. And we will say here, here, and here. No, no. Silence detector. And we want to import our silence detector. That's what we want. And back down here, we want the lower one to be a silence detector. We don't care about, or screw it. Let's just keep the visuals and say set speaking, set speaking. Now what? Save this and run it. And no, 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 nothing works. No. Okay, that works. That doesn't work. That works. That that works? No. Okay. So, are you at least kind enough? Or you can't see that. I should have that on the main screen. Can we see what's going on? Um, do we see this is running a lot? That's because it is this. No? Audio visualizing. Hold on. Hmm. This breaks everything for unknown reasons. And try and move this one inside. Doesn't matter. It shouldn't matter where it stays. Mm, it's not a lot of logic. Okay, we can do a simpler one. Simpler detector. And we'll just do like this. Yep. And we can say button, set speaking, on click, true. That should do the trick, right? Hmm. So we'll do another one. And simpler detector. Does this work? No. Okay. Why? 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 This is the most painful thing about web development. It's like things break, and you are sort of sitting here and saying, hmm, oh, never mind. Set speaking is not defined. This is a user error, my error. How is set? Oh, you are actually right. And no speaking. Does that mean the other thing worked as well? Silence detector set speaking. Uh, can we just wire this one up here? Mm -mm 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 -mm. Speaking now. Aha, that works. That's a start. So we can pass down state. Fine. Hmm. This thing over here, we still don't know why exactly it works. Is it this? It might actually be this one. I could imagine that because if we call visualize and it's like, I'm gonna draw, like, okay, then this changes and it will be repeating itself over and over and over again. Plausible? Highly plausible. Mm, gonna do this and set timeout. Hmm, hmm. If this is right, we should see the FPS be reduced to like 1 every second. I think. Hold on. We need to save. So, yep. This is why it repeats itself. So this is why it works. So if we do this, go back here, and we find our other piece of logic over here. Down here, they had something like silence detection here. So here, we now have this. That's speaking. Does this work? No? Bummer. Does this work better? No? Huh? Why not? Oh, we probably don't need that like this thing, right? Um, so we can go like this and this and this and this. Mm-hmm. Mm-hmm. We'll do a quick, simple test. No, that will work. That's for sure. Um, so this thing here, let's debug this. Test 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh? No? Test one, two, three, one, two, three. Test one, two, three, one, two, three, one, two, three. So what I'm trying to figure out here is, are we spinning up multiple components or multiple loops, or are we just having one? Seems like we're just having one, which is cool. So this is still going. Off you go. Seems pretty good. Now we would like to stop doing a lot of things the moment our speak turns or is speaking state turns to false. So we're just gonna move this into a, we're gonna call this, mm, delay before checking audio jack. Let's see if we can find a more valid name, but this is 50. That's our, so things would still be the same. I can put 250 in here. It's still running relatively often. Now it should do this every second. If it doesn't, something is definitely off. Hmm. I, there has to be. We'll redo the loop logic then. So we're getting running twice. Not sure why. This. Hmm. But this does not have to be a React component like this, right? It could just be a function. If we say boop, 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 we don't need the props. Still have this. We can do this, this, and just say if we don't have a stream, nothing else matters. Return. And say console error, no stream found. Otherwise, if we have the stream, we'll do this, this, and we are down to this one here. And we'll say uh, create a loop that runs every clear interval. I'm not sure where that comes from. Oh, interesting. Let's rid ourselves of this for a sec. And do we even need the use effect? Can we just say, hey, do this? Have an interval. Mm, mm. Does this work? Definitely not. Hmm. We'll go back. So this works. This works. Mm-hmm. We'll just try this. Um, console log clean up here. And this theoretically should just do the trick. Our silence detector clearly runs 2 times. Why? I'm not sure. Maybe it's the way we do the loop thing. Let's start to track our data to see if this actually changes anything. That was in. Okay, so we already do that. But we want to silence this one in here for now. No more locking. We'll turn it on. So this is running. Now we're speaking. Let's load the model and see what happens. We are live and it works and we are seeing data. Now we can keep speaking for a while to see data grow and grow and grow, but the moment we stop speaking, we should flush everything and hopefully we'll see data drop down like rather quick. Doesn't seem to be exactly the case. Let's try one more time. Um, Wonder if it's because it doesn't stop the stream exactly, so we're still running the stream. That means we need two different streams to do this, one to monitor the audio and one actually for the model. That might come with some overhead, but still not terrible. Let's pause. So at least for now, it doesn't seem like our data is ballooning like it did before. It's actually quite reasonable. The issue we had before was that when we kept speaking, it would balloon and balloon all the way up to like first 20,000 and 30,000 and 40,000, and eventually our app would basically crash. So this definitely seems bigger, or not bigger, but better. We are now at 25,000, and so this clearly works. It's not no longer getting out of hand. We can actually see it drop to zero the moment we stop speaking, which is kind of what we want. And our CPU usage is also like half of what it started with, or where we ended before we actually had to fix up. At least theoretically, it looks like we actually fixed things quite well. Whether this works in real life is TBD, but we can figure that out. I just said another filler word, unfortunately. So we need to go back and add that to our array of filler words. If one says TBD, that should be flagged as a filler word, right? So the good and bad thing here is like since we clean this up, our words per minute drops off the moment we stop speaking, which is great. We like that, but at the same time, it's also kind of wonky. You would like it to maybe link around and even out as you stop speaking, so it's not just like you stop, now we stop. It can almost feel like too responsive. This actually works quite well. It's utilizing web GPU. We see here that we're utilizing 20% roughly. This is like 70 combined. So Electron gets the last. Windows Server and OBS takes up a lot. So this would, let's assume, be faster if we're not streaming at the same time. Obviously, when you're on a call, that's going to take up some power as well. So the biggest risk with this is the resource management or it being a resource hawk. There's really only one way to figure out, and that's to make a binary that's not attached to anything and try not to stream at the same time. But theoretically, this works, which is pretty cool. So in the past, there's been like no way we could have it running like for this long without things going haywire. Hmm. Now I'm just gonna like let it run for a bit and see what happens. Like my laptop is getting toasty, that's for sure. But I think that's okay. We also have a Chrome render helper somewhere going nuts. If I kill this, oh well, it went away again. I mean, I feel like if we had two streams, that would probably be the next thing. Let's open up Excalibur. Just have this running in the background. Let me see what happens. What happens? Excalibur here. So we are getting out of the Paincave here because oh, this is what we're looking at. We seem pretty good. So we now have the added benefit of detecting whether the user is speaking or not. That's working. That's wildly beneficial both to this idea and our past idea, which might be a second iteration of uh like this one. And this is truly exciting because what we are building, for those of you who don't know it, but what we are building has changed since last week. If you just tuned in last week, we are on different plans. Just want to make sure we have the right screens here on the second one. But what we're building has changed a bit, but the requirements are somewhat the same. But this actually works. This really works. And the prototype that I have built immediately course corrected how I think about my speech and how I verbally articulate myself, to put it nicely. So I'm excited to get this working and running, and hopefully we'll see it doesn't melt down devices across the world. There's only one way to really figure out. If it doesn't, I think we can build a viable product. If it does, well, we need to figure out what to do about that. What we're using is still super early, state of the art, can almost not be done use it like in the browser kind of stuff. So there's hope, but I think the next steps here is optimize. So let's group this and move it out of the way here. This we did. Now we need a new one here, which is spin up two streams. Stream one, listen to users' mic. Stream two, hand off to model for transcription. Flow. So what will happen is when user is speaking, detected in stream one, what needs to happen is turn on model. Actually, what needs to happen is create stream for model to use. I think start transcribing or transcription, run until silent, until user is silent. When user is silent, destroy stream stop model. Probably in opposite order. Stop model, destroy stream. Because right now we are just purging, which definitely helps. Um, for stream two, and for stream one, listen for mic audio if within threshold speaking equals true, if below threshold speaking is false. Oops, headset ran out of power. Hopefully you can still hear me. Looks like you can. So that's what needs to happen. We'll probably do that tomorrow as our tomorrow project. That would be fun. Our thesis is this. That's bad. Optimal performance because model is the hawk. And I think we can listen to the stream. Like we tried that for the audio visualizer, and it's super duper lightweight. Doesn't really like doesn't really take a lot. And for all we care, we could theoretically just use our audio visualizer. That would work. And then we just need to wire up the second flow. And do that, we are sort of in a good place. Sweet. I think that's it for today. So it's been 4.5 hours. So we know what we're up to tomorrow. I might just think about things until tomorrow and try things here and there, but like officially we are wrapping up until tomorrow. So that's it. Thanks for chiming in, coming with me into the cave, and I will see you all tomorrow. Cheers.